Welcome, everybody. Good morning, good afternoon, good evening, depending on what time zone you're in. I happen to be in Southern California this morning, so it's a lovely, beautiful, sunny morning here. And welcome to our webcast. This is the next in the series on Informix and the Internet of Things. And just a couple of logistic announcements. This webcast is being recorded, and hopefully we'll have it up on our webcast replay site by the end of the week. If you want to ask a question, the best way to do it is to hit the chat button. There's a balloon in the top right on your screen that says chat. And send a chat, your question as a chat message, and go ahead and send it to everyone. That way Mike can see it in addition to me. And I am Lester Knutson with Advanced Data Tools, and I'd like to now turn it over to Mike Walker. So Mike, take it away.
All right, thanks, Lester. So my name's Mike Walker. I work for Advanced Data Tools, and as Lester said, this is the second webcast in our series. This time we're talking about Informix TimeSeries and how it can be used with the Internet of Things. So last week I did a webcast, and that was more of an introduction to the Internet of Things and how Informix fits into that. This time we're really going to focus on TimeSeries. It's a feature of Informix that is just ideal for the Internet of Things. This will be followed by two more webcasts that Tom Beebe will be doing. The next one on June 23rd will be about setting up a database server on an ARM computer and the different types of hardware that can be used and why Informix is a good fit. And then our final webcast in July, the end of July, will be about setting up Informix. Not specific to ARM or anything, but like an introduction to getting up and running with Informix. Okay, so what we're going to talk about today, Informix TimeSeries. We're going to first of all start off with a summary of some of the things I spoke about last week in the previous webcast about Internet of Things, what it is, capturing some sensor data, and using an ARM computer as a smart gateway. Then I'm going to launch into TimeSeries and explain what it is, what it's all about, and then go through some examples of setting up a very simple, regular time series, and then how I set up TimeSeries for the sensor data. Then I'm going to talk about the virtual table interface, or the VTI, which is another way to get to your TimeSeries data and display it in a relational format. I'm going to show you an example of displaying that sensor data on a web page and pushing that data out to the cloud, and then viewing that data from the cloud. An example of some APIs that can be used to pull that data and displaying them on a web page, and also showing some graphs and stuff on a website. Okay, so the Internet of Things. So just a brief recap of what the Internet of Things is. It's all about bringing together the physical world and the digital world. So we're talking about sensors or gathering information from the physical world using smart gateways to store that data or push it out to the cloud. And it's all a bunch of interconnected devices. Some examples of these you may have already seen, like these smart thermostats, thermostats in your house that you can control from anywhere using just a smartphone, door locks, lights that you can turn on and off, again, with just with a phone or anywhere where you've got an internet connection. So an example of this, and here I'm showing an example of what I did last week, but a lot of Internet of Things solutions will follow this kind of model, where at the sensor there will be a smart gateway. There'll be sensors sending data wired or wirelessly to this smart gateway. You can query the smart gateway using just a web page, just to interrogate it and pull off the data and display the current situation of things, the current values. But you can also push that data out to the internet, to the cloud, where you can access it anywhere. So the information or the demonstration and the webcast that I ran last week just to summarize where we left off there, or what we covered. So we had a set of sensors, some different sensors that I put together, some based on an Arduino, some not. And that sensor information was stored on a Beaglebone, which is just an ARM computer, a Linux computer, real small, real cheap, small footprint. And I ran Informix on it, the Informix database, a full-blown database. And I transmitted the data from the sensors to the gateway over a radio network. In my example, I used XBs, little XB radios using the Zigbee protocol. So all that data was coming into our gateway, and that data just was displayed on the screen. And we could also make decisions on our gateway, like controlling devices. And in the example, I turn on the light. And you can also send yourself texts and emails and make those decisions locally. But that's where we finished off. And that webcast is available as a replay online. So I'm not going to go over much of this in this webcast, but please refer back to that earlier webcast for more on this. Okay, so here's the data coming in. I'm doing this right now, for example. Let me just bring up. Okay, so here's an example of right now. This is real time. This is sensor data in my house being collected from 4 different sensors. There's 3 inside the house and 1 outside. No, there's 5. I've got 4 inside the house, 1 sitting out on the deck, and they're all sending temperature information. And then a couple of the sensors are sending humidity information, light information, and one of the sensors has it's got a compass on it. That's the heading there, and a dial you can turn, and a switch. So all of that information is being transmitted to my smart gateway, the Beaglebone in my case, and I'm just displaying that on the screen here in a Python script. So what are we going to do with all this data that's coming in to our gateway? We're going to store it in a database, and I'm using Informix, and especially I'm using a feature of Informix called TimeSeries, and I'll be covering that for the majority of this webcast. Okay, so why do we want it in a database? Well, we want to keep a history, so we can go back and see how things have changed. We can run local analytics, and we can share the information in the database between different applications. Okay, so stepping back a bit, so for Internet of Things, there's a problem with all this data. The problem is there's just so much of it. So think about all of these devices out there. There's soon to be an estimated tens of billions of these devices, and they're all generating a bunch of data points over a period of time. That could be a long time. So we really need to start thinking about the best way to store this data. And we need to store it efficiently. We need it efficiently in different ways. We need to be able to retrieve that data quickly. We need to be able to save that data quickly. And we also need to really think about how we can store that data without taking up too much room. So with that in mind, I started running some numbers. And so smart meters are a big thing. A lot of houses and businesses now equipped with smart meters. So they're measuring electricity over very frequent intervals. So you can then check your current electricity usage. The utilities can see how much electricity you're using at any point in time, that kind of thing. So according to some report that in the middle of last year, there were about 50 million smart meters in the US. Now, if you start thinking about this, out of these 50 million meters, if you're reading 1 sample every day, you've got about 18 billion readings over a period of 1 year, just 1 year. Now, if you start reading that every hour, it's not long before a year's worth of data is 438 billion data points. Now, most utilities want to read this data more frequently than that and take readings every 15 minutes. So for 50 million meters, you're now at 1.7 trillion data points. And you've got to think those data points isn't just a meter reading, there's other metrics that are measured also. So you've got all of these values and it adds up to a lot of data. So a single utility company might have over 5 million meters. And if you're reading every 15 minutes, 1 year's worth of data is 175 billion readings. So you start getting into some pretty big numbers here. So then start thinking of the storage all of that is going to take up. And then start thinking if you want to store it for 5 years, 10 years, and so you've now got even more data that you've got to store. You're talking a lot of storage now. And then think about trying to generate a bill for a customer where you want to pull out data reading, the meter reading for the current point in time and let's say 1 month previous. And then maybe you want to show a history of how that customer has used their electricity over the previous year. So you've got to be able to get to that data pretty quickly. Okay, so this is where time series comes in. A time series is a really efficient way and a very quick way to store and access a lot of data points that have a time component. So the data is not stored in a regular relational model. Instead, it's stored in a columnar form, and I'll explain this in a minute. So think of the sensor data that I'm capturing. We've got some really simple data elements, nothing fancy. We've got temperature, we've got humidity, we've got a light level, in some cases we've got a switch. It's real, just a simple integer or a decimal value. And these readings, we get them at regular intervals from when the sensor transmits them every few seconds. In my case, I'm only storing them every 20 seconds. I'm writing to the database, but they've got regular timestamps on them. Now, time series, we're not talking about an option here for Informix. This is included with all editions of Informix. It's not an add-on. So anybody with an Informix database, a newer version will be able to access time series. So before we talk about how time series, what it looks like, let's look at a traditional relational model of how you'd store this kind of sensor data. You'd have a parent-child model, most likely. Your parent table would have information on your particular sensor, its location, both in a name, an ID, all sorts of things. For a smart meter, this would be perhaps a residence, so you have a meter ID, you have an address or a customer number, something like that. Now, the data would be stored in another table. You'd have a child table. So that child table would have the information that you want. In this example, we've got a temperature reading. Okay, it's got a timestamp of when we received that temperature reading. And it has to have a foreign key back to our parent table. In this case, we're using a sensor ID. So there's our data point with our timestamp. Now we get another data point a minute later. Okay, so we have another record, a whole new record inserted into our child table with the same foreign key, with the timestamp, which in our case is a minute later, and our new temperature reading. And we get another reading, same thing. We've got a foreign key, we've got a timestamp, and our temperature value. Okay, so each of these records has to have that foreign key, and it's always the same because we're pointing back to the same parent record. We've got this timestamp in here, but we know each time we get a reading, it's going to be 1 minute apart. And also, every time you store one of these records, there's an overhead. It's not a lot, but it's going to add up over time. A few bytes for storing every record. Okay, but really all we want in this from these readings is our temperature values. And so we can plot these over time. Okay, so there they are, but that's all we want. So now let's look at a time series model and see how there's much less duplicated information. So with time series, we store all of these data values in the same record. So we have one special column, a time series column, in our table. We've only got the one table now, and we just append the data to that column each time we receive a new value. And in our case, we're using a regular timestamp. Each time we get a data value, we know it's 1 minute later than the previous value. So if we're using this regular time series, we can work out the timestamp for any value by its offset. So now we don't even need to store the timestamp. So it's pretty obvious we've got a lot less overhead now, and this data is going to be much more compact. So what does the data look like? So let's look at an example here. These are the sensor readings that I'm capturing. And I've got my Arduino sensor here. And you can see that the time series column has a bunch of values in it. We start off with an origin of when this time series started. We've got a calendar, tells us that we're storing data every 1 minute. The container where it's being stored, some other values, and also it's a regular timestamp. We got some nulls in there which show that there was no data retrieved in these time intervals, and then it's followed by data which is shown in parentheses. These three values are the temperature, the humidity, and a value indicating how bright it is. It's a light level. Okay, and all of those sets of data are in parentheses separated by commas. So that's what our data looks like in time series, and I'll go into that in a bit more detail in a minute. So now you can see everything is stored in a single record, no matter how many readings we have. So our case earlier where a utility company has got 5 million or more meters, their meter table will only have 5 million records. Even if they've been capturing data for a year, 2 years, or whatever, they'll just have a bigger time series column. Okay, so how do we create a time series? And I'm going to lead you through the steps. There's about 5 steps to create a time series from scratch within the database. So the first step is to create a calendar pattern. So this defines the valid time intervals for time series data. So when do you expect to get data? When do you not expect to get data? And that's used with the calendar table, which has the start and date time of the pattern, and the calendar pattern will be repeated in there. So those two things work together, so you know when valid data values come in. Then we create a row type to store the time series. And this is just it's a user-defined type, and it will always contain a timestamp and then the values that you actually want to store, like the temperature, the humidity, and such. Then we create a container for that time series data, which references the row type, and that says where do we want this data to be stored. So actually physically on disk, or an area on disk, a logical area on disk, where to store all that time series. Then finally, we create a table and we specify this time series column, the row type that we just created. And I'll go ahead now and give you examples of each of these steps. So first of all, creating the calendar pattern. So this defines the valid time intervals for time series. So an example I decided to use for this was if we're keeping track of the number of hours an employee works during the week. And in this example, I'm going to say there's only 5 work days in a week, Monday through Friday, which means we're not going to be storing data for weekends. That pattern, we'll set up the pattern like that so that we don't need to store almost like placeholders in our time series for weekends when we know we're not going to get any data. And we use that pattern so we can work out the offsets. So I decided to start this pattern on a Sunday. So you can see here our units are of day. So we're storing, that's our resolution or granularity of our time series data. And we're going to say the first day is off, it's invalid. Then we've got 5 days that are valid to receive data, and another day is off. So obviously, I'm starting this calendar on a Sunday. So the first day, the Sunday, is off. I'm not going to expect data on that Sunday. Monday through Friday, those next 5 days, we can receive data, and the following Saturday, no, we can't get data on that day. Okay, the next step is creating the calendar table. So here, these tables like calendar table and our previous table calendar patterns, these are built-in time series tables. So we don't need to create these, we just start inserting into them. So the calendar table here, I'm creating a calendar called weekcal, and I give it a start date, and the pattern starts normally the same. and I give it our pattern name, which is our work week day, which is our pattern 1 day off, 5 days on, 1 day off. And I'm starting this on a Sunday. And I have to do that because otherwise my offsets would be wrong. Okay, the third step, we create a special row type. So this is how we want, or where we say what data we really want to store. So I'm creating a row type. Here it's called hours worked. I've got my timestamp in here, and this has to be of this precision. We have to go down to a fraction of a second to 5 decimals. And then we store the data element. And here I'm storing the number of hours, just a decimal value. So that's the data we're really looking to store here. Then we're going to create a container. So this says, where do we want the time series data to actually be stored? Here we use a built-in function, tsContainerCreate, and we specify the DB space. For those of you who use Informix, know that a DB space is a logical area of disk where we set up ahead of time, where we can store tables, and in this case, where we can store our time series data. And we give it the row type, so it knows how to set up that container. Okay, our last step is actually creating a table where we're going to reference this time series column. So in this table, emp hours worked, I'm storing an employee ID, just an integer value. And then the second column here is our special time series column. Again, we use this reserved word time series, and we give it our row type. So what we're saying here is in our employee hours worked table, we've got employee ID. That's going to be followed by a couple of values, a timestamp and the hours worked, which has already been defined as our row type. Okay, actually creating this, this time series happens when we insert our first record. So before we can start inserting our time series data, we need to set up our employee record. So I've got a little insert here, employee ID of 1, and we use another built-in function, tsCreate, which we're going to use to create a regular time series. We specify a calendar, and here we're specifying a timestamp of when we want our data to start, and our container where we want the data to be stored. Now, the examples I'll give in this webcast will all be with regular time series. Regular time series use a pattern where we expect the data to come in regular intervals. In this particular example, it's every day, and other examples I'll get onto, there'll be every minute. Time series can also be used to create irregular timestamps. So when there might be a long period of not receiving any data and then suddenly getting some data that may not conform to any particular schedule. In those cases, that's an irregular time series, and that will store a timestamp in the time series record, and use a different function to create that, the tsCreate for irregular. Okay, now what I've done here, this particular insert, the 13th, when I created this, actually is a Sunday. And you remember I said earlier that a Sunday is not one of our patterns. So is one of our off days when we defined our pattern. So now when we actually look at that data, remember this is an empty record just created. The origin has been bumped forward to the first valid day, which is going to be that following Monday. So we've gone, when we're actually looking at the data now, and these are those special, it's almost like metadata. We've got our origin specified, we've got our calendar, our container, threshold, and it's a regular timestamp. And these, oh, see, there's the start date getting bumped. And these square parentheses there, the square brackets, shows that there's no time series data because we haven't added anything yet. We're about to do that now with an update. Why an update instead of an insert? Well, we're not actually inserting more records into our time series table. We're updating our time series table with new values. Remember, we're not creating more records for each data value, but instead just appending to the same record. So we use an update on our table. We're using another function, put_elem, to put our data value in there. And we're storing a timestamp. This happens to be for the Monday. Well, this will become relevant in a minute. And I'm storing 8 hours. So for Monday, this employee ID 1, worked 8 hours. I'm going to store another value. Here I'm going to skip a few days and put a data value in for Friday. And you'll notice that even though in the second insert I specified a timestamp, that is of no relevance in this particular example because our resolution is just at a day level. So I've got data values for Monday and Friday. What happens if I try and put a data value in for Saturday? Remember, Saturday is not a valid day based on the pattern that I created, which is Monday through Friday. So if I try that insert, I get an error. I get an error that's not a valid day in the calendar. Okay, I'm going to insert one more data value, this time for the following Monday. So I inserted data for Monday, the Friday. I tried to do something for the weekend. That didn't work. And then now I'm going to insert something for the following Monday. So another data value. Now let's look at the data that got inserted after I do that. So I just did a query in this example on our employee record. And we can see the time series data at the bottom here. So we've got a value of 8, followed by 3 nulls, followed by an 8.25 and a 7.75. Now, you can see that it stored a value for each of the valid days in our calendar. So let's just look at the days that, the weekdays here. We had data inserted on Monday. Nothing was inserted for Tuesday, Wednesday, or Thursday, but we need those nulls in there to preserve the offsets so that we know that the next data value was for a Friday. The data value after the Friday is a Monday. Now, notice there was nothing for Saturday and Sunday. That's because this needs to match our pattern, and Saturday and Sunday are not valid work days. So we don't need to store these extra nulls in there. Okay, so that's an example, really just a simple example of a regular time series and how we set it up. Now, I'm going to show you how I set up the time series for the sensor data that I'm capturing. So here I didn't bother creating a calendar. Informix has some built-in calendars. So there's one for retrieving data every second, every hour, every day, and so on. And these are all built-in ones. And I'll show you the one I'm using. It's a minute one, but that'll be when I actually insert our first data value or insert our first record. So first of all, I'm creating a row type. Okay, in my row type, I've got the timestamp, and I always need that. And that's followed by the data values that I actually want to store. So I've got a temperature, a humidity, and a light level. So in this example, that's all I'm storing. The second step, I'm going to create my table. So here, in my table, I want to store a sensor ID, the XB name, and a location. And that's followed by our special row type. So you could imagine that kind of expanding, the sensor reading expanding into the timestamp, the temperature, humidity, and light level, those 3 data values, all stored in this sensor data column. I'm going to create a container. Remember, that's where I want that data to be stored. And here I'm saying store it in the DB space sensor DBS. All right, let's start creating our first record. And this doesn't have any data in it. It's just an empty record, which we're then going to add time series values to. So here's my insert, just a regular SQL insert, but with our function tscreate. And here's where I mention the calendar. This is the built-in calendar. And here I'm using the ts1min. Obviously, I'm storing data every minute. I can store data more regularly than that. I could store data every second if I wanted, except the granularity of that is still at the minute level, that if I do insert something within the same minute, I'll only see the latest data value. So if I insert something at, I don't know, 1:02 p.m. and 5 seconds, and then insert another data at 102 and 20 seconds, it's that later data value will overwrite the earlier one. So that's the granularity of the data I'm storing. So here's my insert to create an empty sensor record. I specify the container and the calendar. And now when I start getting my data in, I just run a simple update. So I update the sensor record for the particular record I'm looking for. In this case, is where the XB name is R03. And I use the built-in function put_elem and give it my row type, or give my column name, and then I give it the data, which has the timestamp, followed by the 3 data values. I've got temperature, humidity, and light level. And I cast it here to the particular row type. So I included this here. So in the demonstration that I showed last week, and the script I'm running now, it's a Python script. It's running simply on the Beaglebone, and every time I get a data value, I store it in an array, and then at regular intervals, I dump that array into the database. And this is exactly the same update that I'm using. So let's take a look at the data. So I can query that data. So it's just a regular SQL statement. Select star from sensor where the XB name matches R03, so it's been equals R03. And here's our data. And I can show you an example of that. Here's the data coming in. But what I can do is just run a DB access command, which is Informix's interface to the database, just from the command line. So here's just the first 100 records, single record, first 100 time series values. So I can see our origin, the calendar, that metadata information, followed by some nulls, followed by, within each parentheses, our 3 data values. Now, why have we got these nulls at the beginning? The reason is that I created this record with this timestamp on January the 18th at 6:30 p.m. I created this. That's the origin, and so everything is from this offset. So I know that this null value here meant I got no data at 6:30. I got no data at 6:31 or 6:32. The first time I started getting, because I know each of these is a minute apart, the first time I started getting data would have been at 6:30, 31, 32, 33, 34, 35, 6, 7, 8, 6:38, or maybe 6:39, and then that's when I got my first data value in. And then each of these, each minute that followed, I stored a new data value. So that's what the data looks like. Okay, back to the slides. Okay, if I want to query a value for a particular timestamp, I can use this function, the getElem function, and that will return data in this format. You can see I've got my regular values there, and then our time series value, which is in this format. It's a row with our timestamp and then our 3 data values. Now, some of the time series functions, because you now got all these additional functions exclusively for time series, they can get a little bit involved, but there are a lot of them. They are documented, but it is you need to learn all of these new commands. Something that makes it a lot simpler is something called the virtual table interface. So the virtual table interface is a view that goes against the time series data and displays it in more of a relational format. So it'll show the timestamp for every value and break out each of those data elements so they look like a new field or a new column or their own columns. So to create a virtual table, you use another function, the tsCreateVirtual tab, and you specify just 2 values, the name of the virtual table interface you want to create and the time series table to create that VTI on. So here I'm creating a virtual table called sensor VTI against the sensor table, which has my time series information in. So once I do that, and now I query this table, I see instead of getting one record with all of those timestamps that we were just looking at, I see that we get one record displayed for every timestamp value. And it skips the nulls automatically because essentially that's no record for that period of time, for that timestamp. And here I can see, here's the data which I received at 1839. So that's because the nulls were skipped. And here's my temperature, humidity, and light level, and they're all displayed as separate columns. Now this looks very relational. The virtual table is really handy just to get used to time series without learning all of those functions. And also if perhaps you've got a reporting tool or something that is not time series aware, then you can use the virtual table instead and have that data just like in a relational format, as if you joined those two tables in a relational model, if you had that parent and child table joined. Okay, so now just that same example I showed earlier for querying something for a timestamp that used a built-in function. Here's what it would look like just from the virtual table. It's just a regular where clause where I'm saying and timestamp equals and then the timestamp, and I get my data back in just a normal way. So this avoids using some of those time series functions. What's really cool about these virtual tables, something I thought was way cool, was you can create a virtual table, this view, on your time series, but then add some functions in there to create an expression. So here I'm creating a virtual table and I'm averaging the temperature, humidity, and light values over a different calendar. In this case, I'm using one of the built-in calendars, the TS 1 hour, which obviously is going to show our data now at an hourly level. And I'm going to get the averages automatically because I put them in this aggregate by. So here's the name of my new virtual table, sensor hourly VTI. And when I look at that, I see the data in a similar format. But if you look at the timestamps, you can now see they're 1 hour apart. We've got 6 p.m., 7 p.m., and 8 p.m. And we've got our temperature, humidity, and light level as before, but now we know that averages within that hour-long period. Okay, so talking more about the row type and a bit of a limitation of the way I've implemented this. So I created a row type with the timestamp, temperature, humidity, and light level. That's great, except some of our sensors, they're only sending temperature. Okay, so what do we see in our time series now? We see a bunch of null values. So we have our, for example, at the beginning here, we've got a temperature of 69.6 degrees, followed by 2 nulls. That's because it never got a humidity or a light level. Now, that's a bit wasteful. What we really need to do is use JSON. So here is when we're using our key value pairs. Here's an example. For example, in this example, if we just receive temperature, humidity, and no light level, this is all we need to store, the temperature and the humidity. So now we're only storing what we receive. And why this is really handy is if I want to add a new sensor. And I've actually been thinking of adding a volume sensor or a noise sensor. So I could hear if there's any noise in the room or what that noise level is. I would have to change my row type in order to implement this. And if I've only got the one sensor doing that, I don't want to be storing nulls for everything. So by going to this NoSQL type of arrangement, where I don't have a fixed schema, I could add a new sensor very easily. Now, the good news is, as of from Informix 12.10, XE4, and beyond, time series now can store JSON data. So I could do this. I wish I could show you an example of it, but I haven't done it yet. It's on my to-do list. But anyway, so okay, now going back to looking at our sensor data, here's a query to show the latest values of each of our sensors. And I can go ahead and run that query. And again, I'm just going to use DB access. Let's look at this one. So here's that same query. And I see my data. So I see my sensor locations, the XB name, a sensor ID, which is actually the XB address, and when we last got a data value in, and the values. And you see for 2 of our sensors, I'm storing the 3 values, temperature, humidity, and light. And then for the other 3, I'm just storing the temperature. So I can see how this by rerunning the query, I can get the latest data. Okay, so that's great. All this is running locally. I'm just running DB access on the Beaglebone. So this is my smart gateway. But what I can do, there's an example. I can now put this same query into PHP. And I can run it in a web page. So I can have the Arduino, not the Arduino, the Beaglebone, which is our ARM-based Linux computer. It has a built-in web server. You don't even need to do anything. It's already running when you get your Beaglebone. And I can put that PHP inside a web page, and I can show that same kind of data just on a web page now. And I've got an example of that. So this is the same thing. I hit refresh, go query the database, pull back those time series values, and I see the data here. And I can then create links to run other queries. And here's something that'll show the current values, the averages and minimum and maximum within the last hour and the last 24 hours. So I haven't saved any more data, but that will change. What I can also do, now I've got all this data locally and in a database, I can start running additional things. And here I've got a way to graph that data. And I'm using jQuery, jplot to produce these graphs, which is, so I'm just querying the data, I'm querying that time series data, and then passing it to those routines to plot these graphs for me. I can see how the temperature and everything has changed over the last day. And I've got examples of those in the slides. So I was using jqplot, jQuery plugin, and I'm sending it JSON formatted data. And I also use those VTIs on the expression I explained earlier, where I can average the values like by hour or by day. And I use those VTIs for the graphs over a longer period, for like the last 30 days. I don't want to have to get data for every minute if I'm plotting a graph for like 30 days. That's just too much data. So I'll do it by get the average for every hour and pass that to the jQuery plugin. Okay, so this is great. I've got all this time series. It's stored on my smart gateway. I can run queries against it locally. The web pages are served up locally. It's great. Except this is the Internet of Things. I want to use a smartphone and look at this data from anywhere in the world with a connection and in real time or close to real time. So what we can do, we can push this data out to the cloud. So there's several sites you can use to put that data in the cloud. And once it's in the cloud, you can just use your smartphone to connect to the cloud, pull that data down. You create a private cloud, or you could avoid the cloud and just run, if you're depending on your business, you could secure all that data within your business, have a secure connection to it. But here I'm using the cloud, and that allows you to view that data from anywhere. APIs are supplied, so you can add data to it and pull the data back and view it in different ways. So I used a site here called Exively, and here's an example in Python just one way to do it. There's different APIs you can use. But you specify a key. I've shortened the key up here, and a feed ID, and then you can send it a timestamp and then the values. Or you can use a JSON format, and this is what I do now, where you specify particular data streams. The data streams I've highlighted here: temperature, humidity, and light, and the timestamp and the values. And I can show you what I'm reading now, what I last uploaded in the output file of the upload. So here's the latest upload I did to that site, where I've got my data streams, and then I'm uploading every 2 minutes. I change that just for this demonstration. So I've got a timestamp. So it's 12:42. I uploaded a value of 76.6, and then a minute later, the same value. Humidity, that did change over those 2 timestamps, and then the light level, that stayed the same. So this is all JSON formatted, and you could see how easy it would be to add new data points. Okay, so now that data's out in the cloud, I can view it immediately. So I'm just going to click on this link, and it'll bring up a web page, and I can see those same data values. I can see it's updated a few seconds ago. I can bring up graphs of that data and see how things changed over time. And all of this is in the cloud. It's not anything that I had to do. Okay. There's the graphs. Now, you can use those same APIs to pull the data down. So I'm going to click on the same link, which has got my feed ID in and a public key. And all of this is how this data is returned to me. Again, in that same key value pair, and I see, let's see. So for example, the light level, I see ID light, current value is 70, and it's then my timestamp, which is in UTC time. Okay. So I get that just by passing in this URL. So I can then take that data. Oh no, well we can also use those same APIs to get graphs. So I'm just going to click on this, and it's not prepared ahead of time. Here's this URL. I can change this. I can change this URL, specify different values. For example, 72 hours, and I can change the color, grid lines. I can make it a big thick line. Can't remember what all of these values do. There's the name. I could change it outside temp and change the size. Let's make it a bit wider. And there. Oh, spelled temperature wrong, but there. So I can just change that by changing the values I'm passing to the API. So with all of these APIs, it's easy to create a web page or display these values on the web page. And anybody can go to this link. This is my own web page. I'm just going to click on it. There's a picture from last night. That picture doesn't refresh. That's the view from under my deck here. And you can see the latest temperature, the humidity values, and I use that same API to display the graphs. I just display that on my web page. Now I give a little example now. Anybody can go to this web page and see the temperature in my house. Okay, so that was the Xively Cloud. IBM have the Internet of Things Foundation. Now, this is their own cloud-hosted service for Internet of Things, It's part of their IBM Bluemix platform, and it uses Informix TimeSeries. It won't say that on there, but that's the technology used behind the scenes because it is such a good fit for storing this time-related data. So Bluemix, if you go to Bluemix, and it's free to try, you can just go ahead and choose the services that you want to employ. And one of those is Internet of Things, and you can just add this service. And then you can register your device and use the MQTT protocol to start sending messages over to the Internet of Things Foundation, and it will be stored in the cloud. Something nice that they have on there is these recipes. So how to get started using the Internet of Things with whatever setup you've got. So I'm just going to click on this and show you what it looks like. So, oh, this is good. Look, you've got a Raspberry Pi here. A few other things. Let's click on the Raspberry Pi. So this is the recipe to get a Raspberry Pi connected to Bluemix. So if you look here, you'll see instructions on how to set it all up. Okay. So I'm not going to go through this, but it's certainly worth checking out if you want to get this up and running pretty quickly. I've just got one slide here about Node-RED. So Node-RED is a very cool tool where you can create these flows. You can have the inputs and outputs and conditions, all things, pull in data from elsewhere, and you can map it all graphically through a browser. Uses Node.js and run on a Pi and a Beaglebone. So something I haven't played with yet, but got a link here, and I'm looking forward to giving this a go. It seems very cool. That's the end of my webcast, but I've added on a few links here to find out more about TimeSeries, IoT on Bluemix, and Docker. I mentioned this very briefly last week. So Informix, if you want to get up and start using it really quickly, there is a Docker container for it. And I've provided a link here. And it's the Innovator C edition. It has some limitations, but it's still a full database. Our next webcast will be in 3 weeks' time on June 23rd. Tom will be doing this, Tom Beebe. Oops. So Tom Beebe will be running this presentation, and he'll be talking more about the different ARM processors, the different hardware applications, and also Informix, and why Informix is such a good fit to run on an ARM-based device. Okay, all right, I'm going to open things up for questions. So at the top of your screen, there should be an icon. We're going to leave everybody muted, but go ahead, and if you do have any questions, type them into the chat window, and I should be able to see them. Nothing. I will say this webcast has been recorded, and it will be placed on our website and on YouTube. So if you do want to go back and review anything, then it should be there within a few days. And you can always email me if you have any questions. I'd be happy to answer them. I will say TimeSeries is a very exciting thing. It's been in Informix for a while, and it is just such a good fit for Internet of Things. Okay, I'm not seeing any questions here. Give another few seconds, otherwise I'm going to end this webcast. No. Okay, well, thanks everybody for listening in, and feel free to email me if you've got any questions. Thank you, everybody.
Hey, thank you, Mike. This is a great webcast, and everybody please tune in for Tom's webcast in a couple of weeks. Have a good day.